All right. This is the Chapter 2 test review. Test will be tomorrow. First question, and I like these few questions because it shows you how we can use sinusoidal graphs. When you hear the word sinusoidal, it's not just sine. It's any graph that repeats itself. So sine, cosine, tangent, these are all called sinusoidal graphs. Okay? But it's pretty cool to read these questions and see the applications of trigonometry in real life, because this is really how things work. They're able to model some really important things using sinusoidal functions. Okay, so each time your heart beats, your blood pressure increases, then decreases as the heart rests between beats. A certain person's blood pressure is modeled by this function, where P of t is the pressure in millimeters of mercury at time t measured in minutes. They want us to find the amplitude, period, and frequency of P given that equation. So what's the amplitude? 20, good. What's the period? How do we find it? 2 pi divided by 160, pi, right? Your pi's cancel, you get 2 over 160, which is 1 over 80, which is the 0.01251, right? So D it is. How do you find frequency when you know period? It's the inverse. Frequency is the inverse of period. Yep, frequency is the inverse of period. So if I know the period is 1 over 80, frequency is 80. So the period is telling me how many times it repeats, or what time it takes for that to repeat. Okay? And frequency tells you how many times it happens in that period. That's just the inverse. Okay, number 2. Each time your heart beats, your blood pressure increases and decreases. There's the function again. So now we're trying to find if a person's exercising, his heart beats faster. So what does that do to the sine graph or the cosine graph or whatever the graph is? If it beats faster, I want to be in here. Okay. So if my traditional, that's my heartbeat. If it beats faster, right? So the time for it to complete one full rotation has increased or decreased? The time it takes is decreased. So that's frequency. Or period, sorry. Period's decreased. Which means if frequency is the inverse, frequency must have increased. It's the inverse. If period decreased, frequency increases. Okay? So period decreases, frequency increases, letter A. Does that make sense? Okay. Astronomers believe that the radius of a variable star increases and decreases with the brightness of the star. The certain variable star has an average radius of 25 million miles and changes by a maximum of 1.5 million miles from this average during a single pulsation. So I'm just sketching this. To me, it changes from that 25 by 1.5. Okay? So I'm going to be at 25 here, and I think my function is going to be like this, where this is 1.5. Because its radius is at 25, and it pulsates, it changes 1.5 from that radius. Yeah. And so this tells me the vertical shift. This tells me my amplitude. Does that logic follow? Make sense? Okay. The time between periods of maximum brightness is 5.4 days. The time between periods. So that tells me the time it takes for it to go through one rotation. To get that number, I would have had to have taken 2 pi over the coefficient, whatever that was, to get 5.4. So to get that coefficient, I've got to divide 2 pi by 5.4. Okay? So I'm looking for a shift of 25 with an amplitude of 1.5, and this is how I would write that period as a coefficient of t. Kind of seeing how these are created. Okay. Are you good, Allie? Okay. All right. Let's just do this one. I know we've got multiple choice, but we'll just do it, and then we can compare to the answers. So, for tangent, where are my asymptotes, my vertical asymptotes? For not this one, just tangent of x. Where are my vertical asymptotes? Negative pi over 2, pi over 2. Yep. So if I just draw one period and I draw my graph, it's going to look something like this. That's what normally tangent looks like. Now it's wanting me to shift which direction? Right pi over 4. Okay? So if this is pi over 2, all I'm going to do is shift it right pi over 4 units, and everything just moves. There's my new asymptote and my new asymptote here. And then, I don't know, we'll use red. It's going to go through, really it should have gone through this point, or pi over 4, yeah, this point. Sorry, didn't graph it very well, but you get the idea. So in your mind, you kind of know what you're looking for on the choices. So first off, cotangent, cotangent, sine or cosine, sine or cosine. That's pretty easy. That's the only one it could have been, because I didn't have any negatives in front to flip it. Right? So it's that one. But we could kind of look at it. We have pi here. Pi, unfortunately, on this graph was split 5 ways, not 4. Right? So this is pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5. So you kind of have to figure out where pi over 4 would fall, you know, in that area. So you could see if you had more than one graph, that's what you would have to do, is probably figure out on this that it looks like pi over 4 is going to be right there. And that was the whole shift over. Okay. All right, cosecant is the inverse of?
Sine.
Sine. Okay, let's just look at the graphs. Okay, I've got 3 here, and they all have the same period. So now I really am going to have to kind of graph it and figure things out. So,
You can figure out the shift.
yeah. But what I want to do first is figure out where those asymptotes should be. Sometimes when you look at a transformation, the easiest thing you can transform is the asymptotes. Because if you can see where the asymptotes shift, then you can find a graph that matches that shift. Okay, so I'm looking at cosecant, inverse of sine. Where is cosecant undefined? Where sine is 0. Where is sine 0?
0, pi over 2, or 2 pi.
0 pi, 2 pi, right? 0, let's just call this pi. And 1, 2, 3, 4, 2 pi. Okay, remember, if this is 1, I'm going to have, sine looks like this, right? So I'm going to have a point here and then a point here. So my traditional cosecant graph will look like this.
But then you got to move it to the left.
Yep, so that's my traditional cosecant graph. Okay, but the 5 really doesn't matter. That just means this point's 5 now. So let's just take a look and see if we have any. Do they all start at 5?
No.
That one starts at 1. This one, yes. This one, yes. So I've eliminated this one just by the amplitude. So now I can look at these two.
That one moved the wrong way. D.
So it's going to move left pi over 2. So this new asymptote should be at pi over 2. This one should be at or negative pi over 2, pi over 2, right? So I would say that's negative pi over 2, pi over 2. But this one is also. So now the one that's up, that's going up, should be the one that moved left. This one, the one that's going up, moved right.
Yeah.
That one moved left, so B it is. All right. Assuming an angle in quadrant 1, I'm just going to do this. There's theta. Find the exact value of tangent of inverse cosine 4/5. Well, inverse cosine 4/5 would be labeled like this, or I can fill in this as my height. Now if I do tangent, it's 3/4. tangent of that angle. See how that worked? Questions on that process?
Can you repeat that?
Yep. So this is always an angle. So it's asking me in the first quadrant, where is cosine? What angle is cosine equal to 4/5? Well, I'm calling it angle theta. And then I'm labeling where cosine would be 4/5, alternate or adjacent over hypotenuse. I know it's a 3, 4, 5. Now I want to find tangent of theta. Tangent of theta is 3/4. Good there? All right. Normal monthly temperatures for Omaha, Nebraska. It's interesting. We got Omaha here. Recorded below. Where do I want to do this? I'm going to do it. January, I'm just going to plot these. I'm going to do it in tens. That's good enough. So 1/21, 2/27, 3/39, 2, 3, close to 40, 4/52, 4/40, 52, 5/62, 6/77, 8/74, 9/65. It's a little high, but 10/53. 11/39, 11, 1, 2, 3, 4, and 12/25. So 12, I'll just do it close.
Well, has a period of 12.
Okay, write a sinusoidal function that models Omaha's monthly temperature variation. That's A. And then use the model to estimate the normal temperature during the month of April. The normal temperature during the month of April. Okay, so it's kind of a... There is my... So I would call that 12 months would be one period. Okay, so I would take 2 pi, right, over 12. So I know that's my period.
So you cancel out D.
Yeah, D is not an option anymore. Now, if I do that, I do have I have a shift of 1 out of 12. 1/12 of that. So what's 1/12? Which way? Those two are going, this one's going left. Well, we canceled that one anyway.
Yeah.
So I'm assuming all of those shifts are correct because that's the only choice. So 7 pi over 6 works. My amplitude,
It has to be sine. Because cosine.
yeah, if I start at 0,
means you only have C.
if I start at 0, and if I shifted it up to this point, that first point is 21, right? I don't know where 28 comes in. But since these are both 49, if it was cosine, it would be, that would be 1, it would be starting, and it would go up like that and down. This would be 1 amplitude above what this was. You know what I'm saying?
Yeah.
Like, because sine looks like this. Cosine starts there and comes up. So whatever that starting point is,
It would be an amp.
does it go down first? Did I do that right?
Cosine goes down first, right?
Yeah.
Yeah. Yeah. I really hope I...
I'm thinking here. At 0, why do I not know this? Well, let's look. Do I not have cosine up?
Nope. You have sine and now cosine.
I think cosine fell down.
That's it.
What's that? That's sine. There's cosine. Yeah. Yeah. Cosine starts at 1 and goes down.
Yeah,
So it would have to be a negative for it to be cosine,
Yeah, it would
right?
have to be negative because it would just go down if it was 21 degrees, which would mean it has to be sine, so it would only be C.
Only be C. And does it seem like this is 49 shifted from 0 to 49 though?
No, that's the weird thing though, that I don't understand.
So it almost seems like if it's 7 pi over 6, and that's the only one it could be, it's shifted right 7 pi over 6. Well, if it's sine, this is not 7 pi over 6. 7 pi over 6 is almost a full, I mean, it's more than.
Yeah, it's a full pi.
So if I were to take this cosine and have this be my point where the cosine starts here, and then it goes down, it's still going to have a period of 12, but you see how much it had to shift over to get to that point? There's your 7 pi over 6 that had to shift all the way over here, which means if this is my peak, well, the peak happened where? January, February, March, April, May, June was my high. Well, let's call it 77. 77, and then it started at 21. What's the difference in 74 to 21? 9 is 30, 49 plus 7. So they're calling that 49. I mean, that would be about where your shift would have to start for it to start right here.
Okay.
You know what I'm saying?
So
So it actually is cosine.
Okay. It's just
And you would have figured that from this because the shift was so big. Yeah. So it is this one right here. Does that make sense? It took a little logic for me to get there, but that 7 pi over 6 was way too big of a shift because this is definitely not 7 pi over 6 here.
Yeah.
If this is,
I mean, maybe if you did it in like radians.
well, but pi over 6 is your period.
Actually,
Yeah,
never mind,
so
that would
it's-
still probably be like a 1.5
Yeah.
something.
Okay. Yep, that was a tough one. All right, arc cosine. So tell me again which quadrants arc cosine exists. Where is it restricted? You're close. First is right.
First and second.
First and second. Remember, cosine is restricted from 0 to pi. Sine is restricted from negative pi over 2 to pi over 2. So sine's restriction is first and fourth. Tangents is first and fourth. Cosine's first and second from 0 to pi. Okay? So we know we're dealing with an angle that's either in this quadrant or this quadrant. It's negative, so it's got to be this quadrant. So I can now draw my angle. Now I can label it. This is negative 7. This is the square root of 130. And I'm trying to find sine, so I'm going to have to find the other side. It's probably going to be 9, I'm going to guess. But what is 130 minus 49? 81, sure enough. Okay, so I've got my triangle labeled. So now I just find sine of theta, because all of this right here is just theta. Right? It's an angle that I've created.
And it can't be C, D, or A.
So it's 9 over square root of 130. Can't be
I like
negative.
that they have a square root in the denominator.
I know, but they do. So
It kind of
if you had thought the only places it could be is 1 and 4, your answer would have been negative, which would be wrong. B is your answer. All right. Write an equation of a tangent function with period 3 pi. Well, I take pi over 3 pi, and that's what? 1/3. So I'm going to have I don't have any, I do have a vertical shift of 2. So it's going to be tangent of, I'm going to do 1/3 here, x plus pi plus 2. And if I wanted to, I could go ahead then, I could just say x over 3. Either one of those. Make sense? Okay. Assuming an angle in quadrant 1, let's just do, find the exact value of cosine of inverse cotangent 12/5. So inverse cotangent is tangent inverse of, you know what I mean? Tangent would be 5/12, so this is 12/5, right? And now I've got to find the hypotenuse. 145 plus, is that a, that's a triple. Okay, and then we take cosine. So that's the answer.
Explain out.
State the amplitude, period, phase shift, and vertical shift. Amplitude, that's easy. Vertical shift, that's easy. 1, right? So now we need the period.
1. Or pi.
2 pi over 2 is pi. Okay. And now the phase shift. I need to factor a 2 out, right?
Minus
So it would be minus pi over 4.
minus pi over 4.
You follow that?
Yeah.
Okay.
Yeah, because we take the 2 out.
Does arc sine 300 exist?
It would be in the 4th quadrant.
Remember, sine of 300 is a ratio. 300 degrees is where? 4th quadrant. Its reference angle is 60. So sine would be negative square root of 3 over 2 of 60 degrees, right? Okay, so when I take arc sine of this, that's equal to arc sine of negative square root of 3 over 2. So what do you notice about anytime you have arc sine, what's always here? Is it an angle or ratio? Arc sine ratio. You don't take the arc sine of a degree. You take the sine of a degree. This arc sine of something equals an angle.
So it does.
So it does not exist.
Yeah, because you're trying to get an angle for an angle.
Yeah, you can't take arc sine of an angle. You take sine of an angle, take arc sine of a ratio. So that tells you what about this one too. Does not exist.
No, but
No bueno. Okay, locate the vertical asymptotes and sketch the graph of y equals secant x minus pi plus 3. Well, secant's the inverse of
cosine.
cosine. Where are the asymptotes before a shift? Where cosine is 0. Pi over 2, negative pi over 2, and so on and so on. It wants us to shift that pi. So used to be, the asymptotes would have been at pi over, negative pi over 2. If I shift it pi, it's going to be here, right? And it was at pi over 2. It's going to be here. No, it was at pi. No, it's at pi over 2. Shift it pi. Was it pi over 2? Shift it pi. Right? Will those be my new asymptotes? So the asymptotes really didn't change.
Did you shift it left?
Yeah, I did. But they're still good,
Okay.
because it really didn't change. If I go pi over 2 and I shift it 1 pi, it'll be here. Okay? So what shifted, though, was what was up and what was down first. Right? So normally with cosine, because it starts here, and goes down, my first point will be, what, here, and then down here. Right? But I'm shifting them right, so this point will be here. I can't get this gone. And this point will be down here. Right? So now I know, and it shifts up 3. So this point moves from 1 to 4. And this point moves to negative 4. No, this point moves up 4 too. 1, 2, 3, 4. Should be it. It's at negative 1. It shifts up 4. 1, 2, 3, 4. It's here. This one was at 1. It shifts up to 5, doesn't it?
If it's a negative 1 and it shifts up to 3, it should be 2, right?
If it's negative 1, it shifts up 4. Oh, 3. Hello. I was shifting 4. It's at 1, it goes to 4. Negative 1 up 3 goes to 2. And this is going down, and this one's going up. And then I could just repeat if I wanted to. Does that make sense?
Mm-hmm.
Sometimes getting the asymptotes right and then what the graph's supposed to do in those asymptotes is the easiest way to picture what the shift does. Okay. Let's do the bonus after I do 15. So assuming an angle in quadrant 1, tangent is, this is theta. Now I take cosine, so 5/13. Just draw the angle, draw the triangle, that'll be the easiest thing. Okay, let's do the bonus. The terminal side of an angle in standard position coincides with the line 3x minus y equals 0 in quadrant 3. So this is actually y equals 3x, right? Which means it goes to the origin and goes down 3 over 1. Close enough. There's my line, right? If I draw my triangle, this is negative 1, this is negative 3.
Square root of 10.
Okay, so we want to find sine. Yeah, we need the hypotenuse, the square root of 10. And sine would be negative 3 over the square root of 10, or negative 3 square roots of 10 over 10.
And 16's a lie.
And then 16 is not, yeah, it doesn't exist. How do you feel?
Just small things that I miss.
Yeah?
I forgot the negative.
You what?
I forgot the negative.
Yeah, like that.
Yeah.
Why? It's always the same little thing.
Okay. Test tomorrow. If you, I guess the rest of the period you can review, or you can do some, whatever else you need to do.
Can I do my quiz after school today?
Yes.